Hello and welcome to my tutorial on benzene and its reactions. First off, we'll talk about benzene's reactivity. So in benzene, the region of high electron density above and below the plane of carbon atoms attracts electrophiles, as we found out in the tutorial previous to this. To preserve the stability of the benzene ring, benzene only takes part in substitution reactions. Benzene usually reacts with electrophiles and takes part in electrophilic substitution reactions. So, key definition here is an electrophile. It is an atom or group of atoms that is attracted to an electron-rich center, where it accepts a pair of electrons to form a new covalent bond. I'll come back to this examiner tip in a bit once I show you some of the reactions of benzene. So, with a little bit of nitric acid and sulfuric acid all warmed up at 50 degrees C, you get a little bit of nitrobenzene. And in order to prepare nitrobenzene, the chemical equation is C6H6 plus nitric acid makes C6H5 NO2 or nitrobenzene, which is the product that we want, plus a bit of water as well. And benzene reacts with a nitrated mixture of concentrated nitric acid and concentrated sulfuric acid at 50 degrees centigrade. Concentrated sulfuric acid acts as a source of H plus ions. So therefore H plus ions must be the catalyst in this reaction. Here, that is a nice note summary for your revision. So I recommend you write that down. Nitrobenzene is a pale yellow liquid and is an important starting material in the preparation of dyes, pesticides and pharmaceuticals such as paracetamol. Good old paracetamol, good for those headaches. The mixture is refluxed when all the benzene is added, and if the reaction mixture gets hotter than 50 degrees, then more than one nitro group can be added to the benzene ring. So part 3 now, we'll talk about the halogenation of benzene. Benzene does not react with the halogens on their own. Knowing that because benzene does not react with the halogens on its own, it needs an intermediate. It needs something to physically, I wouldn't say physically carry the halogen, as it doesn't do that. It needs a catalyst to carry the halogen, like iron chlorate, iron bromate, aluminium chlorate, or aluminium bromate. So, if you look at the summary reaction with chlorine down here, we have benzene plus Cl2 diatomic gas with iron chlorate or aluminium chlorate. We get chlorobenzene plus hydrochloric acid. So, chlorine reacts with benzene at room temperature and pressure in the presence of either of those two, or iron itself, to produce chlorobenzene. We'll find out more about why iron does this in the next tutorial when I show you actually the nitty-gritty of how benzene turns into chlorobenzene. Benzene reacts with bromine in the same way as chlorine. The halogen carriers required either aluminium bromate, iron bromate, or iron itself. The product is bromobenzene. So it's the same jobby really, just you have a different product. You have bromobenzene and you have hydrogen bromide instead. Notice the halogen is next to the hydrogen. Good way to remember the chemistry. So I'll come back to the examiner tip now. It is often easier to show the equation by drawing the benzene ring. So first you always start off by drawing your benzene ring. So I'll have a go. Delocalized ring. So benzene plus bromine, for example, goes off to bromobenzene. Which is bromobenzene plus hydrogen bromide. To attach the group to the benzene ring, a hydrogen atom has been replaced. So really you should write C6H5 minus because the hydrogen has been removed. That is the intermediate before the nitro is added. Don't just write C6H5. C6H5 minus is merely an intermediate for this reaction. The final product, which is what the examiner is looking for, is C6H5NO2. H5 is key, so you understand that a hydrogen has been lost. So next tutorial I'll look into more detail about these reactions and how the delocalization ring is broken momentarily and benzene looks a little like this for a time, where A is the reactant and H is a hydrogen atom. But more about that next time, so thank you for watching.